Oh, hey Danny. What's up? What's up, man? How you doing, bro? What's up?
Hello, Joey. There's not much going on in my world. Just checking the time. What about you?
Wow, that's pretty awesome, Danny. Well, me and Tyler were gonna go watch 250 Yo Mama jokes. Can you watch them all? Wanna come?
Of course I'd like to go watch Yo Mama jokes with you and Tyler, but right now, something's on my mind. I heard about this thing called Bioluminescence, and I want to find out more about it.
Bioluminescence? What's that?
I'll tell you about it in Miss Coola's room. We have class.
Alright, now that we're here, wanna tell me more about what you were thinking about? Bioluminescence, I think you said it was called? What's that? Please explain more. I'm really curious.
Of course, Joey. From what I've been able to research, bioluminescence is a form of light created in living organisms via a chemical reaction. Now, since bioluminescence is caused by a chemical reaction, it makes it a form of chemiluminescence. Now, unlike bioluminescent light that we rarely see, the light we normally see is caused via heat, like in light bulbs and whatnot.
Oh, so what you're telling me is that chemiluminescence is a term for light being produced in a chemical reaction, and that this is an example of something we learned in chemistry actually, which is known as a redox reaction, because it has to do with the charges of electrons and the transfer of energy, which is what emits the light? This is crazy. It's crazy how this wraps into what we're learning in our Chemistry 40S unit. Thank you, Danny. Please tell me more.
I know, Joey. Isn't it crazy that this kind of bioluminescence reaction occurs in fireflies, firefly squids, anglerfishes, and a ton of other creatures? It's crazy how they can do it so well. And I even heard that they're the most efficient light producers.
Well then how is this possible? How are they able to create such an efficient way of making light?
Well, you see, Joey, before we get more into bioluminescence, we have to understand a couple key terms, like luciferin and luciferase. Luciferin is the organic substance made by bioluminescent creatures that will come into contact with another substance in order to produce light. Now, luciferase is that other substance. It is an enzyme that when mixed with luciferin will oxidize in order to create light.
Oh, so that's how they work? A chemical reaction between a luciferin and luciferase, which is a type of catalyst, are able to produce a reaction that emits only light? That would explain why glow sticks only glow when you crack them to mix the substances inside, and why fireflies only sometimes glow, and why both of them don't release that much heat.
You would be right if you said that, my young student.
Well, why don't we get to writing down an equation, my dear Daniel? Let's see if we can work this out.
Okay, Joey. I think we got ourselves a great diagram here by putting our two beautiful minds to good use.
Yes, I would agree, Daniel. It seems as though our hard work has paid off. But to be certain, let me read over our equation again. So first off, you have a luciferin, like luminol here, which reacts with hydrogen peroxide and iron to form a compound called 3,4-nitrophenylglyoxal, nitrogen gas, and hydrogen gas, and of course, light. Crazy how we were able to draw a simple reaction like this all by ourselves. Good work, Daniel.
Yeah, I noticed there's a charge on the 1,4-nitrophenylglyoxyl compound, which makes sense because electron transfer would result in a change of charges, just like an oxidation reaction.
Keen observation, Daniel. This is a reaction for when chemists on the crime scene want to see if blood was in a location after possibly being washed away. So they spray the chemical on the designated area for the reaction to take place.
Exactly, because the iron acts as a catalyst and allows the reaction to happen, leading to the blue glow, which would only be produced if traces of iron left over from the blood are in that location.
Well, what about in animals? Let's try to write down what a reaction would look like in one of them.
Well, here's what I got. 1,5-dihydroriboflavin is reacting with pentanol, which turns the pentanol into pentanoic acid and transfers energy in order to release light.
Wow! What another great example of a chemical process that releases light. I think I get the hang of what needs to be in place for a bioluminescent reaction to happen. When else would this take place though, Danny?
Bioluminescence is used in all sorts of situations, Joey, even as form of defense sometimes. They'll do this by distracting, surprising, or even using the bioluminescent reaction as camouflage sometimes. Such creatures that will do this are some forms of plankton, where they actually glow when they detect grazers that eat them, so that they aren't eaten and can ward them off. And that's not even it. Not only can it be used as a defense mechanism, it could also be used as a predatory tool. Some creatures, for example the anglerfish, will actually use it to lure prey so it can catch it easier.
Wow. All I can say is, the Manitoba curriculum is a genius for putting redox reactions into our curriculum, because I think we haven't even scratched the surface of what a redox reaction is. We've only talked about one category, Daniel. This is just incredible. Thank you for showing me what redox reactions are capable of in bioluminescence and chemiluminescence.
Of course, Joey. It was a pleasure learning more about bioluminescence and chemiluminescence with you. And it's a shame COVID stripped the opportunity away from us to learn more about redox reactions, as they are truly so fascinating and enjoyable to learn. Well, I can always tell you more about it. Even right now we can.
It appears as though that was the bell. I believe we will have to continue in our lives with our current knowledge on bioluminescence and chemiluminescence. Perhaps one day we would be able to organize something that would allow us and our fellow students to further our knowledge in this category. Thank you very much for once again, and I will see you later, Daniel.